Apparent weight in a lift. Apparent weight in a lift. Let us consider a body of mass m is situated in a lift. Let us suppose that the rectangle represents a lift and the small circle represents a body of mass m. When the lift is at rest, the weight mg acts in the downward direction and the normal reaction acts in the upward direction. Mg acts in the downward direction and normal reaction acts in the upward direction. If the lift is accelerated upwards, it is shown by an arrow in the upward direction with A represents the acceleration. If the lift is accelerated up with an acceleration A, then a force will be applied on the body in the downward direction. That force will be equal to ma. It is known as pseudo force. Whenever the lift is accelerated upwards, the body experiences a force in the downward direction that is known as pseudo force. So it is represented by ma. So it is written as if accelerated up. If accelerated up, then the force is ma downward direction. Then the normal reaction becomes equal to ma plus mg, because ma plus mg is the downward force. Normal reaction is nothing but reaction. So reaction will be equal to ma plus mg. Hence, normal reaction in the first case will be R1 is equal to mg plus ma. If the lift is accelerated downwards, which is shown by an arrow in the downward direction at the top, A represents the acceleration in the downward direction. If it is accelerated in the downward direction, ma is shown in the upward direction. That represents the pseudo force acts in the upward direction. The pseudo force acts in the upward direction when the lift is accelerated down with an acceleration A. That is shown by an arrow in the upward direction. If accelerated down, that means when the lift is accelerated down, the body experiences a force in the upward direction. In this case, the normal reaction becomes mg minus ma. Mg minus ma, because the resultant of the two forces mg and ma is mg minus ma. This resultant force creates normal reaction. Hence, R2 is equal to mg minus ma. If the lift is accelerated down with an acceleration a is equal to z, if lift is accelerated down with an acceleration equal to acceleration due to gravity g, then normal reaction R is equal to mg minus mg is equal to 0. So the normal reaction will be 0 if the lift comes down with an acceleration equal to g. We can derive the relations for normal reaction using the formula F is equal to ma. We can derive the relations for normal reaction using the formula F is equal to ma. We know that ma is equal to the resultant force. Ma is equal to the resultant force. If the body is at rest on a platform, then acceleration is 0. So Fr will be equal to mg. Fr will be equal to mg, or R is equal to mg. R is normal reaction, that is equal to mg. Then if the platform is moving up with an acceleration a, if the platform along with the mass is moving up with an acceleration a, then R minus mg will be equal to ma, because the resultant acceleration is in the upward direction. Then R minus mg becomes Fr, resultant force. We have the relation Fr is equal to ma, hence R minus mg is equal to ma. If the platform is coming down with an acceleration a, then the relation Fr is equal to ma can be written as mg minus R is equal to ma. Mg minus R is equal to ma. Like this, we can apply the formula F is equal to ma. In the case of lift accelerated in the upward direction, let us apply the relation Fr is equal to ma. Fr is equal to ma. If accelerated upwards, then R will be greater than mg. Then Fr will be equal to R minus mg. But Fr is equal to ma, hence ma is equal to R minus mg. Rearranging this, we will get R is equal to m into g plus a. R is equal to m into g plus a. When the lift is moving down, so the resultant acceleration or the resultant force is in the downward direction. Hence, mg minus r is the resultant force, but Fr is equal to ma, hence ma is equal to mg minus r. By rearranging this, we will get r is equal to m into g minus a. M into g minus a. If a is equal to g, then r becomes equal to 0. If the lift is at rest or moving with uniform velocity either in the upward direction or in the downward direction, then acceleration a is 0. Acceleration a is 0, so resultant force Fr will be equal to 0. Hence, 0 is equal to r minus mg, or r is equal to mg. If the lift moves down with an acceleration greater than g, or if a is greater than g, then the body floats in air. It will not be on the platform of the lift.